design of RCC element. So first one is what is meant by RCC. So RCC is a composite construction material. RCC means it is a combination of concrete and steel. The resting applied the load. The concrete having the compressive strength, the steel having tensile strength. So the interaction between the two material enable withstand the complex loading condition. So it's made suitable for building, bridges, dams and industrial facility and transportation infrastructures. So RC means reinforced concrete is a composite construction material, is combination of concrete and steel reinforcement. So concrete, what is meant by concrete? So concrete means it is made up of cement, fine aggregate, coarse aggregate. The nominal mix up to 25 M25. After above M25 is a design mix. The steel reinforcement having Fe250, Fe415. Its maximum high yield strength steel is Fe415. Mild steel having Fe250. This two steel commonly is used for RCC building structure. So previous days before RCC structure, it is having only PCC, plain cement concrete. So plain cement concrete having only the compressive strength. So no tensile stresses is added. So why reinforced concrete? Nowadays why the RCC is used? So the concrete alone means PCC. So the concrete alone is brittle. The tensile strength only 8 to 12% of its compressive strength. Concrete is maximum compressive strength and some amount of tensile strength is having that up to 8 to 12%. The steel reinforcement embedded with concrete to resist the tension and improve the overall performance. So basic RCC's characteristic means it is a high compressive strength and tensile strength excellent, fire resistant, durability, good bond between concrete and steel. The compared to is cost effective construction, vertile structural support. So RCC is mainly used for building structure. So how to coming from history, the reinforced concrete, the first one is Joseph Aspdin. So first the cement, Portland cement. The cement also known as Portland. Portland is a place. So it is invented is Joseph Aspdin in 1824. After that, one of the first reinforcement concrete boat made up of Joseph Louis in 1849. After that, the Joseph Monnier patented the RCC. So patent person is Joseph. So flower pot and structural application normally used for flower pot. First time is used for flower pot and structural application. After that, the Francis developed the modern RCC framing structure. Then loading structures. After that 1950 onwards, the present the high strength concrete, free stressed concrete, fiber reinforced concrete is nowadays maximum used free stressed concrete. So for free stressed concrete means first stress the steel structure after the concrete is filled. It's having compared to RCC, it is having more strength and performance based design merged. So it is the part of that. So it is a history of reinforced concrete structure. Joseph Aspdin is the first one. After that, up to 1950, the present days nowadays using same high compressive strength, free stressed concrete, fiber reinforced concrete, and performance based design emerged. So it is the history of modern development. Next, so moderning high strength concrete. What is meant by high strength concrete? So RCC means reinforced cement concrete. So high strength concrete means it is having high compressive strength and high tensile strength. The grade of concrete also maximum and steel grade also maximum. Up to M25 concrete is nominal mix. After that M30, M40, upcoming M80, M90 is running there in the situation. So high strength means minimum M60. Then up to M80 it is a high strength concrete. Ultra high performance means above M60 and M80. So self compacting concrete means up to the self compacting concrete is selfly compact itself. Ambient curing condition, the concrete is compacting, that is the self compacting concrete. So fiber reinforced concrete. The fiber is also used to reinforced with the concrete, is having high strength, high yield strength. So it is a fiber reinforced concrete. So nowadays the research going on the geopolymer concrete. So sustainable and geopolymer concrete. What is mean by sustainable? So sustainable means present without affecting the future. So it is a sustainable. Sustainable is the waste materials converted in the future ones without affecting the future. So landfill materials or any other dumped materials is used to in construction work is a sustainable. So waste material is used, the plastic materials, and the agricultural waste, industrial waste, that or the waste is replaced, it is used to concrete structure, it is a sustainable. So sustainable and geopolymer concrete. Geopolymer concrete means it is another type of concrete, it is not having cement, it is only the binder is fly ash. So fly ash is the main component. After the alkaline materials is used to the polymerization present in the concrete, it is having the good strength compared to RCC. So it is a geopolymer is a nowadays research going on more. So it is a main one. Polymerization having ambient curing condition is done to getting the maximum compressive strength up to ultra high performance using the geopolymer concrete. So nowadays used for aircraft structures or the flyover is used for geopolymer concrete. The geopolymer concrete is a sustainable one. It is a main one. So next one is advantage of RCC. So nowadays the topic is RCC, reinforced cement concrete. So reinforced cement concrete having compressive strength, having high tensile strength. Tensile strength means yielding strength. So the yielding strength is coming from steel, iron material. So maximum the mild steel having the yield strength of 250, the high yield strength deformed for having 415, 550. So next one is, it is important one is tensile strength. After that, it is two material used, steel and concrete used, means the RCC going to getting the durable material and fire resistance, economical, easy constructions and long service life. So after that the concrete, RCC means combination of concrete and RCC. So first one concrete. So concrete grade. What is mean by grade? Grade means, it is mean by MCK. MCK means compressive strength. So how to come with compressive strength means, it is a 150 mm cube mold getting the concrete after 28 days 28 days curing that the compressive strength, UTM machine getting the strength getting 20 means the plus or minus 5 mm is the error. So 19.5 or 20.5 is taken, consider as M20. So M25 also consider as same method, the after 28 days strength is designed by compressive strength. So the 25 is the compressive strength, this is the main by grade, meaning that grade of structure. So M20, M25, M30 and M40 is used. Next is steel grade. The steel is the mild steel one is the 250, high yield strength or 415, 500, 550. The 415 is the ductile material, so it is having the yield strength. So up to 600 nowadays is used to that. For bridge construction having above FE 500 or FE 550, normally RCC building having FE 415 and FE 250 used to that. So it is a concrete and steel, is a combination of material of RCC. Next one, what are the loads acted on the RC structures? So the load commonly named as dead load, live load, wing load, earthwork load and snow load, impact load. First one is dead load. So dead load means it is a self load. The self load, the RCC is a combination of concrete and steel. So the concrete having the unit weight. So the PCC means the unit weight 24 kN per meter square. So RCC having 25 kN. So dead load is calculated unit weight into area of the section, the beam or any other building section, we take that. So 25 is the unit weight into area of the section. So it is considered for dead load calculation. After that, calculate live load. So live load is important to take that using the IS 875 code book. So IS 875 having part 1, part 2, part 3. So part 1 is taken from dead load calculation. Part 2 is having the live load. One table saw here, the residential building is assumption made in 4 kilonewton. After that, auditorium or any other apartment is included in the code book available. The code book name is IS 875, part 1, part 2, part 3. Part 1 having the dead load. Part 2 is assumption made from live load. The wind load is considered for part 3 code book, IS 875, part 3. So the 3 loads are important to take that consideration for design calculation. So dead load, live load is normally taken. So the wind load is considered for apartment building or the tower structure. So the wind is acted more area is considered for wind load. So next the earthquake load. The earthquake load is considered for the seashore building or any other building. Nowadays all loads are considered for making the structure. So in the important ones also earthquake load, the dynamic structure, how to make that, it is considered for the earthquake load. After that, snow load. The snow presenting area, you take that snow load and impact load. It is the load acted on the RC structure. Commonly is taking from dead load, live load, wind load. Is normally residential building you take consider the 3 types of loading. After floor finishing all calculated. So next after that the RCC elements. Element means parts. Though the RCC structure made up of slab, beam, column. So foundation it is the elements. Elements means parts of the structures. So first one is slab. Slab is roof structures. The slab having the 2 types, one-way slab, two-way slab, based on direction. Based on support, simply supported, cantilever, continuous. So these are the types of slab is considered for roof structure or floor structure. So the one-way slab. One-way slab means one direction to reinforcement is provided. One direction means X directions or Y direction, you provide the reinforcement. Reinforcement means T. The main reinforcement and the distribution reinforcement is provided for one direction. It is a one-way slab. A maximum, the condition is obtained by the longest span divided by shortest span greater than 2 equal to one-way slab. Less than or equal to 2 means two-way slab. So two-way slabs is very important consideration. The two-way slab is considered for the reinforcement provided in 2 direction. 2 direction means 4 side. This 4 side provide the reinforcement. Consideration is taking for design part having the load maximum means you get the two-way slab. So it is a one-way slab, is two-way slab is based on reinforcement provided. Based on support, cantilever, continuous, simply supported, that is overhanging, so etc. This going on that. The maximum considered as simply supported and cantilever. Continuous is used for the more slab is going on one floor. The rooms, 2 or more rooms are available provided in the floor structure means you take the continuous slab consideration. They are all using slab design. The code book used is IS 456-2000. It is an important code book. Indian Standard 456-2000 code book. It is a design of all RCC structures or RCC element. Slab, beam, column is the element. It is designed by IS 456-2000. So one-way slab on consideration L by Lx greater than 2. Two-way slab means L by Lx less than 2. So cantilever slab means you have to one side is supported, another side is free. Continuous means 2 or more supports presented in one floor. It is a continuous slab. So now we are going to design a one-way slab. So one-way slab normally the RCC structure designed by one-way or two-way. So one-way slab is carried out, some conditions are given in code book procedure. So the IS 456 procedure LY is not like that, it is a longer direction. So longer span to shorter span is greater than or equal to 2 means is designed by one-way slab. The slab bends mainly in the shorter span direction. So the distribution for given to the shorter span and main reinforcement provided is shorter. So main reinforcement means the bar size is included is 16 mm to 25 mm. The distribution for means small sizes of bar. The bar size is having 8 to 12 mm is consideration for slab design. So this is the normally main reinforcement is shortest span. Shortest span means the X direction. So X direction means the length direction. It is provided for the main reinforcement. So this is the design of one-way slab. Next, this is the one-way slab drawing. So the view, one-way slab views is supported by two opposite sides. The load transfer to it is like a beam, it is like a beam. The load transfer to the two beam include using the reinforcement. They supported on all edges. So all edges are supported. So all edges are supported. So L by B is taken from greater than or equal to 2. Longest span divided by shortest span greater than or equal to 2 is a one-way slab consideration. Otherwise, L by B less than 2 means is considered for two-way. Okay, so it is a structural element. Next, design procedure for taking the one-way slab. It is a collection of data. First one is collect the data. Collect the data means the dimension first you collect that in your RCC building, any one the dimension is length and x direction length and y direction length. Maximum the x direction length is taken as clear span. The clear span means end to end support. The column end to end is provided by clear span. Effective span means center to center. The column having one effective thickness. The two sides are column provided. So center to center means width of support is taken for consideration. So it is a procedure. First one is collect all data, all the necessary data. Necessary data means what is the dead load, live load. So dead load, live load is taken from IS 875 part 2 is taken that. After that the design procedure one by one to solve that. So first one is effective span. The effective span is considered as small l. The live load is taken as Q. The floor finished load is normally assumption made from 0.6 kN per meter square to 1 kN per meter square. So these are the material. Grade of concrete and grade of steel is the material. So concrete material is M20, M25. The grade of steel is Fe415 and Fe200. Normally the RCC building structure is taken from Fe415 and Fe500. So next is cover. Cover is main one. The bar provided between the cement covers are provided. The slab is taking 20 mm. The beam is taken 50 mm diameter cover. Column is taking the cover of 40 mm. It is taken from IS 456 2000 assumption. So IS 456 2000 code is the limit state method. So limit state method means the structure is provided within the limit. You have to safety and serviceability provided. So these are the steps provided. After that, the moment calculation, the load is acted, the member means the bending is done. So the bending means moment. So the moment calculation, after that shear is occur. So shear, check for shear and check for deflection is the checking condition of one-way slab. So it is a main important things you have to design the slab design. After that you go for the effective depth. It is the first step for designing this slab structure. So the using codebook name is IS 456 2000. First you take the basic depth ratio. So basic depth ratio, this is the basic depth ratio. It is taken from the page number 36 in your IS 456 codebook. Basic values of L by D. So maximum simply supported means L by D is taken from 20 to 25. After that the cantilever slab means L by D is taken from 7. The continuous slab means L by D taken from 26 in your codebook procedure. So IS 456 codebook procedure, the basic values of L by D. L is the clear span, D is the effective span. So clear span is the collecting data. You take the collecting data and calculated the effective depth. After you calculated the overall depth. So overall depth formula is computing the effective depth plus cover. Cover is mean once when cover is provided between the steel bar, it is a clear cover. The slab having the clear cover of 20 mm. Beam having the clear cover 15 mm. And the diameter is taken from 10, normally 10 or 16 or up to 25 you take any one. It is based on the structure. So normally the within one floor, up to one floor you taking the 10 mm diameter is the used for distribution for. So 10 by 2 maximum taken, it is overall depth calculation. So it is the first step is a depth calculation. So the data is collected only after using the plan. You take only the span value, clear span value. After using the clear span value, you calculated the effective depth and overall depth. It is the first step, very important step. You calculating the depth calculation. So after the dimensions are made, the basic dimension is calculated. After go for what are the loads acted on the slab. So normally already I said that self load. Self load means dead loads. Dead load means it is own weight, own having unit weight. So normally is body having own weight. It is self weight. So it is normally taken from concrete means the concrete is made up of steel and concrete. RCC is made up of steel and concrete. So it is own self weight. So the self weight taken unit weight. So normally unit weight is based on the unit weight 25 is taken from IS 456-2000. The plain 7 concrete means 24 taken. After that brick masonry is 18 is taken from code book procedure IS 456-2000. So unit weight of concrete into area. Area means the breadth and thickness. So normally the slab breadth is taken per 1 meter cube. So it is breadth is 1. So only is considered for thickness only is taken. So thickness only taken for the sulfide. So unit weight into area. So area breadth is 1. So 1 into thickness. So thickness is normally taken. It is a sulfide formula. So after that live load is taken from IS 456-2000 code book. And using the load calculation having one book IS 875 part 2 is taking the live load. After that floor finish is assumption is taken from IS 875. After the 3 loads are sum of them you getting the total load. So the total load is considered for W. After factor load is very important. So the total load means the load having sulfide, lab load, floor finish. Floor finish means it is tiles or any other material is part of floor finish that using that it is a floor finish. The floor finish having permitted some amount of value taken, the load value it is considered for. After factor. So factor load means design load. So if you have any RCC elements you designed it, not taking the total load. So nowadays is taking design load. Design load means the beam is only designed for 20 kilonewton means normally is taking structure having sustainable up to 15 kilonewton. So the maximum limit is the design load, limiting load. So design load is factor of safety multiplication. Safety purpose you have to some coefficient apply. So RCC means the 1.5 is the factor of safety value. So the total load equal to 1.5 into total load. The 1.5 is a factor of safety. Safety purpose, some coefficient value is multiplied in the total load value. So the steel structure means that normally is taken tower. The based on tower structure is taken for 1.1 is taken for steel structure. RC structure means 1.5. Steel structure means 1.15. Based on IS 456-2000 code book. So it is a load calculation. So first one is basic dimension. After what are the load is acted on the elements, acted on the slab. So this is the load calculation. The load calculation is very easy. Sulfide, live load. After that the slab having some amount of floor finish combined that is taken consider the floor finish taken from IS 875 code book. Normally assumption made from 0.6 to 1 kilonewton per meter. So the total load is sulfide plus live load plus floor finish. After that some amount of safety purpose you added this factor of safety value 1.5 for RCC structure and 1.15 for steel structure. So load calculation. So 2 steps calculated after you go for calculating bending moment. So the load is acted on any member means the members will be bending out the moment and shear is obtained there. So what is the moment? So moment means based on your support the moment formulas is changing. So normally simply supported means 2 sides supported for wall structures. The moment formula is WL square by 8. So normally the cantilever slab, the slab is obtained on above the window slab or door slab is taken the moment value. Cantilever means WL square by 2. The continuous slab means is taken from dead load and live load is changing coefficient. It is from IS 456 taken and calculating the moment for continuous. So it is the formula. So simply supported means WL square by 8. Cantilever means WL square by 2. Based on the support condition, the moment will be changed. After the shear force also some consideration. Simply supported means WL square by 2. Cantilever slab means W into L, WU into L, ultimate load into effective span. So WU is the ultimate load. So ultimate load is previous one. After that you calculating maximum moment and maximum shear force acted on the slab. So the load is corrected, the bending is done. After that the design means how much amount of area of steel is provided in the slab structure. So AU, so limited, so limiting. So MU is acted on the structure. The limit is based on your IS 456 within the limit safety and serviceability provided on the all the RCC structure. So the limit is taken from IS 456 2000 code. Check the depth value. It is important one. The limiting moment is considered. Formula is taken based on your grade of concrete. So the grade of concrete is Fe415 means it's taken from MU limit 0.138 FCK pt square. After Fe500 or Fe550 used to means they change that coefficient. So 0.138 is changed 0.126 or 0.144 is based on your grade of steel structure. So it is a limiting value is used for calculating the checking depth. So now first one you calculating the effective span, is checking the depth. It is under or over reinforcement. The section is used. So it is very important step, checking the effective depth. After that, how much steels are provided inside the member, slab member. So AST means area of steel member. This formula also taken from IS 456 2000, the page number 96. The formula is MU is equal to 0.87 FY D minus FY divided by FCKB. So Fy means Fy. First one is Fy. Fy is yield distance. The yield distance is coming from the iron. So Fe is the iron. So Fe 415, that 415 is the yield distance. Stress. So strength means stress. The stress is unit is Newton per mm square. After the AST is the calculated value. It is unknown. After the MU is calculated, applied on the MU value. After that calculating the AST. What is mean by D? D is effective depth. So Fi is the yield distance. AST is area of steel. FCK B. FCK means characteristic compressive strength. Breadth is also. Next, after the calculating the AST, then checking is provided. So checking is very important. Based on your IS 456 limiting condition, you have to check for shear, check for deflection. So it is a main one, check for shear and check for deflection. The check for shear is taken from IS 456 page number 72 on formulas now. The concrete shear strength and steel shear stress is coming there, tau V, tau C. So tau V is the steel shear stress, tau C is the concrete shear stress. After calculating steel having some amount of shear, concrete having some amount of shear, after the concrete is maximum, it is a safe one. The steel having obtained the maximum shear stress means you provide the stirrup on the structure. So after that VU is calculated. It is the checking. So tau V and tau C is calculated. The tau C is maximum means it is a safe structure. Tau C is minimum means it is going to calculate the stirrups provided. Next, check for deflection. Check for deflection is also important one. The deflection means based on your basic value. So basic means L by D value. In your code book page number 36, check the formula. After that calculating the L by D actual. So L by D maximum. So L by D maximum, some formulas are given. L by D basic into some coefficient. Kg, Kf application. The graph are provided in the code book. You take the formula and solve that procedure. So it is the procedure for designing the one-way slab. So the procedure is done. First one, collect the data. Second one, effective span. Third one, live load and floor finish load calculation. After moment, after AST calculated, then go for check for deflection and check for shear. So it is a design completed. So the design procedure is very important based on your IS 456 2000. After you go for some one or two examples given for slab and beam problem. So first one is one-way slab design. So one-way slab design, some examples given. First one is the design of one-way slab simply supported on two opposite sides having effective span 4 meter. So that taken effective span 4 meter. The slab is subjected to live load of 3 kN per meter square, and floor means load already given 1 kN. So already given, you don't given in your question means you take assumption 0.621 kN per meter square. The live load also given, it's not given means you take from IS 875 part 2 taken in your project purpose. So the given data is taken span means length, so it's taken considered for meter. The live load is kN per 1 meter square. Floor finish also taken. After that material, so material means concrete and steel. So concrete having the FCK of 20 means compressive strength, so Newton per mm square, or otherwise megapascals unit is all same, stress megapascal. So next steel grade is FY as 415 Newton per mm square is taken for grade based on your steel. Next cover maximum slab is having 20 mm, beam is having 15. So it is a slab structure. The design of one-way slab, so cover is taken from 20 mm. Unit weight of concrete is taken is a RCC structure, so you have to take the 25 kN per meter cube. So it is a given data, or it's taken from some values, is taken from IS 45642. So first step is calculating the depth. Depth means two types of depth are there. First one is effective depth, second one is overall depth. So effective depth means small d, overall depth means capital D. So effective depth is value taken from IS 456-2000 code book, page number 37. Some basic values are given. So it is a simply supported slab, is taken from L by 20 to L by 25. So L is the clear span or effective span, some given value divided by 25. So 4 meter, 4000 divided by 25 is taken from code book. So getting the 160 L. So after overall depth is taken, clear cover plus effective depth plus 10 mm dia is total depth is there. So first step is calculated. Already the procedure is given for above slide. After that second step is calculation of load. So load is very easy. First one is sulfide, unit weight into thickness. So unit weight 25, thickness means overall depth. So overall depth is 0.18 is taken. After that service load. Service load means live load. So live load is given for one floor finish is given. So 4.5 plus 1 plus 3 is 8.5 kN per meter square. After that third one. So first one is dimension. Normally the dimension of the building is calculated. After what are the load is acted. The load is acted means after that is a slab bending considered moment. The moment is acted means how to sustain the building is some amount of weight is done using the reinforcement and concrete. So AST is calculated. It is the design. Design means what are the materials and what are the some of the given sums are provided. Okay, so next third step is moment calculation. Already said the moment calculation simply supported means mu is equal to Wx squared by 8. It is taken from support condition. So after that W is the ultimate load, L is the effective span. So Wx squared by 8 is getting the unit is kilonewton meter per meter. So next checking the effective depth using the M limit formula. So M limit formula is taken from based on your grade of steel. So the grade of steel is Fe415 means using this coefficient 0.138. So Fe500 means is change that 0.144. After that 1261 coefficient is given based on your grade. The mild steel means 0.126. This is taken from IS 456 code book. After apply the all value, FCK means grade of concrete, so 20, compressive strength, breadth means always slab having per meter length calculation, so 1 meter, so 1000 mm is taken. After that the effective depth is first step is calculated value 160 kN square is getting the answer. So next check is compulsory, so mu less than mu limit means the depth is adequate, is under reinforced structure, so it is safe structure. So after going to how much amount of steel is provided on the structure when using that formula. So this formula is available in page number 96 in your code book. Mu is equal to 0.87 F/AST D minus Fy AST divided by FCKB. So mu is already ultimate moment calculated using WL square by 8 formula. So 25.50 into 10 power 6. After apply the all value. Fy means yield distance, AST unknown, D is the effective depth, Fy is 415, AST is unknown. So FCK into 10. Breadth is always taken from slab per meter length. So per meter 1 meter. So 1 meter means 1000 mm taken. So solving that equation, you get the value of AST is 471 mm square. After that, how many bars are provided? The spacing provided between one bar to another bar. The formula used 1000 AST divided by B. So this formula you calculated using the spacing formula. It is a minimum. So minimum reinforcement provided based on your code book. Some formulas are given. 0.12% of BD. So 0.12% of breadth is 1 meter. So 1000 mm. Effective depth is the calculated value and get that minimum area. So maximum overall area is 471. The minimum area also 192. It is checking AST less than capital AST. It is a safe. So it is a slab design. After that, the design is over. After checking is compulsory. So check for shear and check for deflection is compulsory. Already the design process is done that tau V is the steel having some amount of shear stress. The formula is VU by BD. So VU is shear force already calculated. 25.50 into 10 power 3. Breadth is 1 meter 1000 and effective depth 160. Apply the value and get the tau V. After tau V calculated using the PT, percentage of steel. The PT is done from in your code book page number 74. One tables are here. The PT percentage of steel. How much percentage provided means then formulas are here. 100 AST divided by BD. First PT calculated using the PT value and get the tau C. So tau C maximum means safe in shear. Otherwise the tau V getting maximum means you provide some more steel bars are provided, stirrups are provided and getting to strengthen the slab member. So it is a tau C is maximum, it is safe. So after that checking the deflection. So checking deflection means basic value L by 20. So actual length is 4000 divided by effective depth is 160, so 25. It is a normally L by D is maximum, is safe. So it is safe for within the limit. Then the drawing is compulsory, the plan is provided. After the design of steel is provided. After that the slab also one member. After that the slab supported by beam members. So the beam also designed by same method, only the beam is in your slab design the breadth is taken from per meter length. So 1 meter is the breadth. The beam design is taken from thickness is taken from the breadth. It is the difference between slab design and beam design. Otherwise all are same. Okay ma'am. So some example for beam. What is mean by beam? Beam also horizontal member is support here, roof stress. The beam having two types, singly reinforced and doubly reinforcement. Singly reinforcement by the reinforcement remaining only bottom or top is a singly. The both side or the steel bar provided means doubly reinforcement. So it is a beam types. The slab having two types, beam having two types. Okay, so now I'm going to explain the design of beam. So some examples given. The example is one-way slab design, 4 meter. The slab having the live load, same method follow. So first one is thickness calculation, and second one is load. Third one is check for depth. So check for depth means mu limit equal to 0.138 FCK BD square is based on your the grade of steel. After that checking is very important. So mu less than mu limit means it is under reinforced, it is adequate one. After is greater than means you check the over reinforced section. Over reinforcement section means the steel is having maximum, so it is not an economic one. Under reinforced is the economic design. After that calculating the AST, and it is a reinforcement detail for providing the beam structure. So is normally this is a cross section. These are the bars, tension steel, compression steel. So maximum the number of are provided in even numbers 2, 4, 6, 8. So 2, 4 numbers are provided. After that the 2 numbers are provided is the compression steel. It is stirrup. Stirrup means legged. It is taken as 2-legged stirrup. It is a stirrup formation. 8 mm bores. Minimum 8 mm to 12 mm is taken for stirrup. The main bore is the diameter taken from 16 mm to 25 mm. The distribution for taken from 8 to 12 mm. Okay, so these are the reinforcement detail. This is the elevation. So these are the final design. Provided the 300 mm to 600 mm beam, the 5 bores of 20 mm. So it is the slab design. So it is after that you go for design the beam, and after that column design based on the IS 456. The load calculation is same, the AST calculation is same, only the changing the moment only change based on your support structure. After this the foundation design. So it is the RCC structure. After you go for construct the building structure. So thank you so much for having the opportunity. Thank you very much.